Chapter 2. Basic Electronics. Ohm's Law. Ohm's law is a fundamental principle in understanding electric circuits. It states that in metallic conductors at a constant temperature and in a zero magnetic field, the current flowing is proportional to the voltage across the ends of the conductor and is inversely proportional to the resistance of the conductor. The law can be represented by the three equations: V equals IR, I equals V, R, or R equals V, I. These equations allow you to find the value of any one quantity in a circuit, provided the other two are known. For example, to find the voltage across a resistor, you would multiply the current flowing through the resistor by the value of the resistor. It's important to use the basic unit of measurements when using these equations, such as volts, ohms, and amperes. Power law. The power law states that the power dispersed in a device is inversely proportional to the squared value of the voltage across it, P power, V voltage, R resistance, I current. P equals V2, R2. It can also be stated as the power dispersed in a device is directly proportional to the squared value of the current going through it. P equals I2 XR2. Power law can be simply stated as P equals VXI2. Electronic components. LED lamp. The solar night light uses a high-power 1-watt LED lamp with an operating voltage range of 3.2 V to 3.6 volts and a maximum current rating of 350 mA. A current limiter, a 10 ohms resistor, is included in the prototype to decrease the current draw to 100 mA when powered by a 3.7 V lithium battery. The temperature of the LED heatsink is observed to stay stable at 30 degrees Celsius at this current level. Lithium-ion battery. The solar night light uses a 3.7 volts 220 mA rechargeable lithium-ion battery, which is commonly found in laptop and camera battery packs. This type of battery was selected because of its longer lifespan and higher power density. The high cell voltage of the battery allows the light to be powered by a single cell, making it simple, easy, and cost-effective to build. The battery can run the LED lamp for 20 hours on a full charge, and with a 100 mA current draw, the daily depth of discharge is 60%. The small size of the solar module used eliminates the need for an overcharging controller, as the battery will not overcharge under daily use. Additionally, the lithium battery can tolerate deep discharge, so an over-discharge controller is not necessary. This simplifies the design of the lamp. Solar, photovoltaic module. In order to power the LED light for 12 hours, consuming 100 mA, the solar module must deliver a daily energy requirement of 1.2 Ah. Considering an average of 3.28 effective sun hours per day and a voltage of 3.7 with 80% charging efficiency, the required solar module capacity is 1.7 Wp. A locally available option is a 1W module with 10 polycrystalline cells, which is suitable for charging the 3.7 V lithium-ion battery. Master switch. A manual 3P slide switch is added to the circuit to disconnect the battery from the circuit. This feature prevents the lamp from turning on when it is stored or transported in a dark container. Additionally, it is a safety requirement when shipping the equipment. Resistors. Resistors are one of the most commonly used electronic components that create specified values of current and voltage in a circuit. Basically, the function of a resistor is always to be against the flow of current through it, and the strength of this opposition is called as its resistance. There are different kinds of resistors that vary in size and color depending on the power that they carry. For the solar night lamp, you will be using 3 types of resistors in varying power. 2 pieces of 1 k ohm 1/4 W resistor, 1 piece of 10 k ohm 1/4 W resistor, and 1 piece of 2 W 10 ohm resistor. Diodes. A diode is an electronic component that allows the flow of electricity in one direction while blocking it in the opposite direction, acting like a one-way valve in various circuits for protection. The solar night lamp uses a 1N5819 Schottky barrier diode. The Schottky barrier diode is commonly used in electronics, known for its unique properties that make it useful in various applications where other types of diode don't perform as well. It has a low turn-on voltage, fast recovery time due to its small amount of stored charge, allowing it to be used in high-speed switching functions and a low junction capacitance. Transistors. Transistors can be considered as a type of switch or gate for electronic signals and also regulates the current or voltage flow. They can be used as amplifiers or switching devices. As amplifiers, they are used in high and low frequency stages, oscillators, modulators, detectors, and in any circuit needing to perform a function. In digital circuits, they are used as switches. For the solar night lamp, you will be using IRF 510 transistor and general purpose transistor 9014. Testing instruments. Multi-tester. A multimeter, also known as a multi-tester, is a device used to gather data about electrical circuits. It combines several measurement functions in one unit, such as the ability to measure voltage, current, and resistance. Multimeters can use analog or digital circuits and are commonly used in basic fault finding and basic field service work, as well as troubleshooting electrical problems in a variety of industrial and household devices. The most basic measurement provided by a multimeter is continuity, which determines whether a circuit is complete or not. To perform this test, the device is set to ohms, and AC or DC depending on the current to be measured, before the probes on the device are inserted into the circuit. If the circuit is complete, it will read 0 and 0.05 ohms. If it reads infinity, it indicates that the circuit is open and can be considered a problem. Basic soldering procedure. 1. Clean the surface of the PCB. A clean surface is very important for a strong, low-resistance solder joint. 2. Component placement. In general, it is best to start with the smallest and flattest components, resistors, ICs, signal diodes, and then work up to the larger components, capacitors, power transistors, transformers, after the small parts are done. 3. Apply heat. Apply a very small amount of solder to the tip of the iron. This helps conduct the heat to the component and board, but it is not the solder that will make up the joint. 4. Apply solder to the joint. Once the component lead and solder pad have heated up, you are ready to apply solder. Touch the tip of the strand of solder to the component lead and solder pad, but not the tip of the iron. If everything is hot enough, the solder should flow freely around the lead and pad. You will see the flux melt liquefy as well, bubble around the joint. This is part of its cleaning action, flow out and release smoke. Continue to add solder to the joint until the pad is completely coated and the solder forms a small mound with slightly concave sides. If it starts to ball up, you have used too much solder or the pad on the board is not hot enough. 5. Inspect the joint and clean up. Once the joint is made, you should inspect it. Check for shorts with adjacent pads or poor flow. If the joint checks out, move on to the next. See video for details of basic soldering.
Clean the surface of the PCB. A clean surface is very important for a strong, low-resistance solder joint. In general, it is best to start with the smallest and flattest components, and then work up to the larger components after the small parts are done. Apply a very small amount of solder to the tip of the iron. This helps conduct the heat to the component and the board. Once the component lead and solder pad have heated up, you are ready to apply solder. Touch the tip of the strand of the solder to the component lead and solder pad. If everything is hot enough, the solder should flow freely around the lead and pad. Continue to add solder to the joint until the pad is completely coated and the solder forms a small mound with slightly concave sides. Once the joint is made, check for short circuits with the adjacent pads.
Assembly of solar night lamp. Snug fit the solar module PVC pipe into the PVC coupling. Attach the solar module assembly to the soda bottle to put together the whole lamp. Cover the solar module or bring the lamp into a dark room to test if the solar night light is properly working. Refer to the next scene for the illustration of this procedure.
Snug fit the solar module PVC pipe into the PVC coupling. Attach the solar module assembly to the soda bottle. Cover the solar module or bring the lamp into a dark room to test if the solar night lamp is properly working. Refer to the testing module for the proper procedure.
Proceed to Chapter 3 for continuation of this course.